Hello everyone, welcome to this tutorial in which we are going to discuss a problem called add 1 to the number. So let's have a look at the problem statement. So the problem statement is we are given a non-negative number represented as an array of digits and we need to add 1 to the number. That is, we need to increment the number represented by digits by 1. So for example, the digits are stored such that the most significant digit is at the beginning of the array. For example, if the number is 123, then it is represented in an array as 1, 2, 3. Okay, so as you can see, the most significant digit, which is 1, is present at index 0, that is at the beginning of the array. So this is a very important problem to understand how to deal with such numbers when it is represented in the form of array. So it has been asked in Google and Microsoft interviews previously. So let's have a look at the sample case. Suppose as we have discussed, the vector has 1, 2, 3, then the returned vector should be 1, 2, 4. Why? Because if this number is represented as a array, so we add 1 to it, that is to the end of the array, so it becomes 1, 2, 3 plus 1, which is 124. So we need to return 1, 2, 4. Okay, this number represented as array. But there is one special case, that is if 0 is present at the beginning, 0, 1, 2, 3, then output should be 1, 2, 4. As you can see, 123 can be written as 0, 1, 2, 3, or any number of trailing zeros can be present, but we need to output without trailing zeros and not with the trailing zeros. Okay, so this is another special case that we need to handle here. So need to remove all the trailing zeros in the given array before outputting it. So in such problems, handling the special cases is also very important, and we will have a look at it. If there are no such such cases to be handled, then it's a very simple problem, but handling such cases requires us a lot of logic in order to get it done. Okay, so you can just pause this video, think for a while how will you solve this particular problem, and then you can think about the special case, how you will approach it. Then you can approach to the solution that we are going to discuss. Okay, so we hope that you have thought it on your own. Let's have a look at the logic. So as all the elements of the input array represents digits, they can only be from 0 to 9, right? Because as the number is represented in the form of digits, even 10 could be represented as 1, 0. Okay, so each of the array element is a single digit from 0 to 9. Now adding 1 to the number is same as adding 1 to the last digit or the rightmost array element. So as you can see, adding 1 to 123 is same as adding 1 to the least significant digit, which is the rightmost digit. So 1, 2, 3, so just add 1 to this and it becomes 124. Okay, so this looks very simple, but now comes the main important thing. What if the number is 129? Okay, then adding 1 to 9 will become 10, so we'll have to send the carry here. We need to propagate carry here, and each time we might have to propagate carry here to the left. Suppose if the number is 999, okay, so then in the form of array it would be represented as 9, 9, 9. Okay, so in that case, when you add 1 to the least significant digit, so it keeps propagating the carry bit. Okay, so when you add 1 to this particular 9, so it will become 10, so you will write 0, then you will move right, so again it will become 10 by adding carry to 9, so again 0, again it will become 10, and finally this. So when the input array is 999, you need to output this particular array, which is 1000. Okay, so this is another special case that needs to be handled. So keep moving towards left until the current element is 10. Okay, why so? Because when we get 10, there is a need to keep propagating the carry bit onto the left. If the element is not 10, that is 123 example, if we add 1, it becomes 4. So there is no need to propagate the carry bit, and we can as it is output it as 124. Okay, but when it becomes 10, then we need to keep propagating the carry bit, and that's why we need to keep moving towards left until the current element is 10. Now in order to remove the trailing zeros, start an iterator from the beginning till the end and break it once non-zero element is encountered. Okay, why so? Because as you can see here, we just need to avoid the trailing zeros. So even if the number is in the form of this, that is 0 is in between, the output should be this. Okay, So as you can see, we just need to remove the trailing zeros and not all the zeros. So that's why we need to break the loop when one first non-zero element is encountered. This means that we have handled all the trailing zeros, but handle the case when the non-zero element is 10. So how to handle this 10 case? While outputting the digit, suppose in this case, okay, when you will transform 999 to adding 1 to it, so it will become in this form because there is no need to propagate to the left. But when the first element is 10, you need to explicitly handle it by breaking it to 1 and 0 in the output array. Okay, let me repeat. When you keep adding 1 to 999 each time, it keeps becoming 10, and finally you are left with this. Why? Because after adding 1 to this, it becomes 10 and there is no left most element onto this, so you keep the array as it is. But while outputting it, you need to output it in the form of this 1 0 0 0. Okay, so this is another very important case. So just handle the case when the non-zero element is 10, then we need to push 1 and then 0 to the vector. As you can see, we first push 1 and then 0 and then the remaining zeros. So this way we need to handle when the first element is 10. Okay, iterate from this point to the end and keep pushing the array elements except 10, as that has been already handled. So once you have encountered 10 or any non-zero element, just keep pushing those onto the vector, and this will give us the final vector. Okay, so just return this vector. So it might look very complex in the form of logic, but when we'll write the code for this, it will look a bit simple. Okay, so let's start with the coding section. You may pause it, you may try it on your own, and then come to the coding section part to understand how we are solving it. Okay, so let's create a vector to test our code. Vector int, let's call it a, and let's put the given case for as input, which is 123, 1 2 3. Okay, so let's do one thing. Okay, first we'll do this only. Now let's call the method. So it will be returning a vector as discussed. So let's collect it in a vector. Answer equals to, call our method add 1, and let's pass the input vector onto it. Okay, and finally we'll be outputting the values present in the answer array. So for auto val in answer, so again this is another way of outputting all the elements of a vector. Just write auto val or int val, as you know that each of the values of the form int val in answer, just output val. It's separated by. Okay, so now let's come to the main logic. Let's define add 1. It should return vector of int, as you can see here. So just return type and input parameters, again vector of int. Let's collect it in a. Okay, so now let's write the main logic here. So first we'll find the number of digits or the size of the vector. So int n equals to a dot size. Now what we do, we handle the special case. Suppose if there are no elements, that is the vector is empty. Okay, so this is also a corner case. So if n equals to 0, that the vector is empty, so you can't add 1 to any number because there is no number. Okay, so you just return empty array as it is, that is a itself. Okay, when n equals to 0, it means that a is an empty vector, so you just need to return empty because there is no number to add 1 to it. Okay, so this is another corner case that is looked upon in the company interviews. Okay, so as discussed, let's come to the logic. Start from the rightmost digit and keep moving left until 10 is encountered. So let's do one thing. First define I equals to n minus y. Why n minus 1? Because if there are any elements, then the last index is n minus 1. Okay, now let's do a of I plus equals to 1. Okay, so what is this? We are just adding 1 to the rightmost digit. As we have discussed, 123 becomes 124 because we need to add 1 to the rightmost digit. So we have done it here. But now If it is 9, then it will become 10. So we keep putting the carry onto the left by making it 1 and 0 separately. Okay, so this case needs to be handled. So what we'll do, we'll just start a loop while a of I equals to 10. And what is the terminating condition for index, as we are moving from right to left? So while I is greater than 0. Okay, this is very important, otherwise you will be accessing the index which is not present. Okay, so this is important. And if a of I, okay, so let me explain you what I am doing here. I minus, and what should be done? A of I plus equals to 1. Okay, so let's see what we have done here. This particular part, we have added 1 to the rightmost digit. Why rightmost digit? Because as you can see, if 1 is added, so the rightmost digit becomes 1 plus to its current value. Okay, so we have done that. Now until the a of I is 10 and I is greater than 0, so we need to keep handling such cases. So what we do, suppose, let me explain you with the help of an example. Suppose your input vector is 9, so your, after adding 1 to it, it will become 10. But as you can see, we don't have to have it 10. Okay, let's do it 1, 9, 19. So it will become 1, 10. But as you can see, the output vector should consist of the digits and not the number itself. Okay, so when a of I becomes 10, what you do, you put a of I equals to 0. That is, instead of 10, you make it just 0. Okay, so just, it's like comma. Okay, you have made it 0. Then I minus. So you move to the next element and then add 1 to it. Why adding 1 to it? Because it becomes a carry bit. Okay, so again, as you can see, 19 becomes 20. So the logic is correct. Just pause it for a minute and it will help you understand what are we doing here. Okay, let me repeat. When you add 1 to the number, it becomes 0. If it is 10, then it becomes 0. Why? Because 10 should be split to 1 and 0. 1 is the carry bit, so the digit becomes 0. You move to the left and you add 1 onto it. It's same as adding carry when we are doing addition on paper. Okay, just think about it. Then let's define an output vector that we are going to output. So vector of int, let's call it v. And what should be done here? So as I mentioned, the next step should be keep moving towards left until the current element is 10. So this has been done in this part. Now in order to remove the trailing 0, start an iterator from beginning till the end. So this is the first time we are encountering the word iterator. So let me explain you how to write an iterator. So we need to define an iterator to traverse to the vector of int. So this is how you define iterator and the name of the iterator. Okay, so this is the syntax to make use of an iterator. Why do we use iterator? In order to loop over all the elements of a vector when we need to access them in the form without accessing their indices. Okay, you can also loop over them for int I equals to 0 in this form, but when we need to point to the elements and not the indices, then we make use of an iterator. Okay, so what do we do after creating an iterator? Let's loop over all the elements. How do we loop over all the elements? it equals to a dot begin. So this is just syntax. If we write it multiple times, we will understand. So as we start from I equals to 0, it is same as writing it equals to a dot begin. That is, we need to loop from the beginning of the vector. It is not equals to a dot end. That is, until we have not reached the end of the vector. So as you can see, I equals to 0, I is less than n, and just it plus plus. So it plus plus is also a valid piece of code. How do we access the element present at a particular pointer or a particular address? We write star. So if star it is not equals to 0, break. Okay, so let me understand what I have done here. This particular piece of code is, I have written it to handle the trailing zeros. Okay, until we encounter 0 from the starting of the array, we need to keep moving in order to update this iterator. So when iterator is not 0, we break it. Okay, so when it is break, what will the iterator be pointing to? Pause it and think for a while. So iterator will be pointing to the first non-zero element after this loop has been broken. Why? Because we are breaking it when the first non-zero digit is encountered. Okay, now we have done it. Break it once the non-zero element is encountered. Now handle the case when the non-zero element is 10. Okay, so as we have seen in this case, if the element is 9, then the output should be 1, 0. Okay, it should be 1, 0 and not it should be 1, 0 and not 10. Okay, because we need to output the number in the form of digit as well. So this is also very important point. So what do we do? If a of 0 equals to 10. Okay, so if a of 0 is 10, so what do? We just do v dot push back 1, and next time v dot push back 0. Okay, so think for a while what we have done. If the element is 10, then we just make it 1 and 0. We split it into 1 and 0. We need to handle this case as well. Okay, so this is what we have written. If the element is 10, then push 1 and 0 separately. Now again, for this it is not equals to a dot end and it plus plus. Okay, so in the usual array, here we write the initialization code. Okay, in the first space. But as you can see, there's no need to put initialization again, as we have broken the iterator here. So we need to start from that index itself. That's why we are not writing anything here. Pause it for a while and think what we are doing. We are just starting from where we have left. Okay, that's why I'm not writing initialization for iterator once again. It will start from where we have left. So if star of it is not equals to 10. Why is not equals to 10? Because 10 we have already handled. Okay, so 10 there's no need to handle once again. So if it is not 10, then just v dot push back what? Star it, and finally return v. So let me explain what I have done here. Okay, so if the vector was 0, 10, 2, 3, 4. Okay, this is the output. Then if this is the number formed after adding 1, so what should be the output in that case? 0 should be removed, the trailing 0 should be removed, 10 should become 1, 0, 2, 3, 4. This should be the output. Okay, so if the first element is 10, that case has been handled here. Okay, and why 10? Why not 11? Why not 12? Because it is a very logical thing. If all the digits are from 0 to 9, after adding 1, the only possibility of a two digit number is becoming 10. It cannot become 11, it cannot become 12. Just think about it. Okay, so that's why we are handling the case only for 10. So if it is 10, then make it 1, 0. So that's why we are pushing 1 and 0. And for the remaining elements, just push them as it is. So if it is not 10 and it is non-zero, just push it as it is onto the vector. So let's have a look what it prints. That's the most detailed explanation we can give for this particular problem. Okay, so just pause it for a while, think on your own, and you will definitely get to understand what are we doing here. So let's compile. Okay, great, compiled successfully. Let's run it. Okay, great. So as you can see, let me zoom it out, zoom in. Okay, so as you can see, where is it? So for 123 we are getting output as 124. Okay, so now let's try a bit complicated cases. Suppose 0, 1, 2, 3. So let's see if it is removing trailing zeros or not. If the input is 0, 1, 2, 3, the output should be 124 once again. So compile it again 124. So as you can see, it is removing the trailing zeros as well. Now let's handle the case for 999. That's the most complicated case that we can encounter when all are 9s. Then the vector should increase its size by 1. So let's see. Yes, as you can see, if the input is 999, the output is 1000, that is 1000. So we have added 1 to the digit. So as you can see, the input was of 3 size, but the output is of 4 size. So that's why it's working for all the cases. And finally, let's put this case. I hope it works for this as well, because we have handed 3. Yes, it is working for this as well. So yeah, it is the complete code. You can just go through it once again for better understanding. Thanks for watching.